Good morning students, welcome back. From this class onwards, we are going to start a very new chapter of your class 11 physics, which is heat and thermodynamics. Under this single heading, heat and thermodynamics, we will be covering three chapters of your class 11 physics, which are thermal properties of matter, thermodynamics and kinetic theory of gases. These three chapters will be covered under the single heading. Please write heat and thermodynamics. Heat and thermodynamics. So, under this single heading, heat and thermodynamics, we will be covering the three chapters of our NCERT book, which are again thermal properties of matter, thermodynamics and kinetic theory of gases. So, this is going to be a really long chapter, right? So, now we shall start our discussion with the topic heat versus temperature. These two are actually very basic terms. Versus temperature, and people often confuse between what is the difference between heat and temperature. Can anyone of you tell me what is the difference between heat and temperature? Please try to answer this question. What is the difference between heat and temperature? Students often see these two terms as similar, but they are actually quite different. So, under this topic, we are now going to see what exactly is heat and what exactly is temperature and what is the difference between the two. So, let us draw one table, and under this table, in tabular form, we will be discussing the differences between heat and temperature, and it forms an important question for your exam also. Right? So, heat and temperature. Heat and temperature. In tabular form only, we will be discussing what are they and what is the difference between these two quantities. So, what is heat? Heat is a form of energy, right? So, if I talk about what do we happen when we touch a piece of ice? When we touch a piece of ice, then what happens is heat flows from our body to that piece of ice, and therefore we feel cold, right? And similarly, what happens when we stand near a bonfire, right? Now, when we stand near a fire, what happens is heat flows from the fire to our body and we feel hot. So, heat is what? Heat is nothing but a form of energy which is producing in us the sensation of hotness or coldness. So heat, so please write down, heat is a form of energy. Heat is a form of energy that produces in us, the sensation of hotness or coldness, right? So what is heat? Heat is a form of energy that produces in us the sensation of hotness or coldness. And then what is temperature? Temperature is a measure of degree of hotness or coldness. कोई भी चीज कितनी गर्म है या कितनी ठंडी है, we judge it by its temperature. If the temperature is high, that means the body is hot, and if the temperature is low, we say that the body is cold. So temperature is nothing. Temperature is what? Temperature is a measure. Temperature is a measure right? So this is definition of heat and this is definition of temperature. So this is one point of difference between the two, their definitions. What is heat? Heat is a form of energy that produces in us the sensation of hotness or coldness. And what is temperature? Temperature is a measure of degree of hotness or coldness, right? So this is what is heat and temperature. Now when I am saying that when I touch a piece of ice, the heat flows from my body to that piece of ice, and because of which I feel cold. And similarly, on the other hand, I am saying that when I stand near a fire, what happens is the heat flows from the fire to my body and I feel hot. So how do we judge from which body to which body the transfer of heat will take place? How do we judge? How do we say that the transfer of heat will take place from my body to ice and from fire to my body, right? So it depends on the temperature of that body. Suppose there are two bodies, body A and body B. Let's say there is a body A and there is a body B. And let's say the body A is at higher temperature. This is at higher temperature and this is at lower temperature. This is at lower temperature. So you need to remember that the transfer of heat always takes from the body at higher temperature to the body at lower temperature. So this will be the direction of transfer of heat. This is how the transfer of heat will take place from body A to body B. Why? Because body A is at higher temperature and body B is at lower temperature. I hope I am clear to you. So temperature is the deciding factor that will decide the direction of transfer of heat. Temperature of the two bodies will decide from which body to which body the transfer of heat will take place, right? And this forms the second point of difference for our table. So please write down the second point. I am dictating, you can write, right? So please write down the second point of difference. Heat flows from higher temperature. Heat flows from high temperature. Heat flows from high temperature to low temperature. Heat flows from high temperature side. Heat flows from high temperature side to low temperature side. Heat flows from high temperature side to low temperature side, right? Full stop. So under this you wrote the second point of difference, heat flows from high temperature side to low temperature side. And now write down under point 2 under temperature. Temperature decides the direction of flow of heat from one body to another. Temperature decides the direction of flow of heat from one body to another. Temperature decides the direction of flow from one body to another. So temperature is the deciding factor which decides that the transfer of heat will take place in what direction, from A to B or B to A, right? And for the transfer of heat, it is essential that these two bodies should be in contact, right? So they may be in contact or they might not be in contact, right? So if they are placed enough close to each other, then the transfer of heat can take place, right? So this is the second point of difference. Now the third point of difference. So can you tell me which is cause and which is effect? Out of heat and temperature, which is the cause and which is the effect? So temperature is the cause and so heat is the cause and temperature is the effect. I am writing the third point of difference. It is a cause. It is a cause and it is an effect. So why it is a cause? Because on providing heat to any body, when we heat any body, its temperature increases. So it is the cause. Providing heat to a body is a cause, and the increase in the temperature of body because of heating, that is an effect. So heat is a cause and temperature is an effect, right? So this is the third point of difference. Heat is a cause and temperature is an effect, right? Now write down the fourth point of difference. Fourth point of difference is, write down the fourth point of difference. The CGS unit of heat is what? So what is the CGS unit of heat? The CGS unit of heat is calorie. So write down the CGS unit of heat is calorie. The CGS unit of heat is calorie. We write it as CAL. Calorie. So calorie is the CGS unit of heat, right? And what is then the SI unit of heat? The SI unit of heat is joule. I hope you know that. For all forms of energy, the SI unit is joule. So because heat is a form of energy, so its unit is also joule. So the SI unit of heat is joule. Write down the SI unit of heat is joule. And can you tell me what is the relation between calorie and joule? What is the relation between calorie and joule? So 1 calorie is equal to 4.186 joule. 4.186 joule. We might need this conversion when we are solving the numerical problems. So it is important to note that 1 calorie is 4.186 joule, right? 1 calorie is equal to 4.186 joule. And can you tell me the units for temperature? The units for temperature are degree centigrade. Degree centigrade is one of the unit of temperature, and degree Fahrenheit is another unit of temperature, and Kelvin. The SI unit of temperature is Kelvin. Kelvin, Kelvin is the SI unit of temperature. So these are some of the differences between heat and temperature that you must know, because they will help you to understand the difference between heat and temperature. So the most important thing is, heat is a form of energy that produces in us the sensation of hotness or coldness, and temperature is a measure of degree of hotness or coldness. And heat is a cause. On the other hand, temperature is an effect. Why? Because on heating a body, the temperature of the body increases. So that's why heat is a cause and temperature is an effect. And if there are two bodies like A and B, then the direction of transfer of heat is decided by what? Their temperature. So you should know that the temperature is the deciding factor for the direction of transfer of heat, and the transfer of heat always takes place from a body at higher temperature to a body at lower temperature. I hope this is clear to everyone, right? So now with this basic knowledge, we are prepared to learn one important concept, which is thermal expansion. So please, I hope everyone has noted down all the 4 points, and now we are going to discuss about thermal expansion. So please write down the heading now, thermal expansion. Thermal expansion. So can you tell me what is the meaning of thermal expansion? This word itself says what is the meaning of thermal expansion. What is thermal? Thermal means heat, and expansion means expanding. So what happens is, whenever any body is heated, its dimensions changes, and usually the dimensions of that body increases. Almost all the solids, liquids and gases expand on heating. But you should know that there are some few liquids, few bodies as well, which contracts on heating, but there are very few exceptions. But almost all the bodies, whether they are solid, liquid or gas, they expand on heating, right? So please write down the definition of thermal expansion. Thermal expansion, write down the heading thermal expansion, and then write down the definition of thermal expansion. So the increase in the size of a body, when it is heated is called as thermal expansion. The increase in the size of a body when it is heated, it is called as thermal expansion. The increase in the size of a body when it is heated is called as thermal expansion. Now there can be different types of thermal expansion. The first one is linear expansion. What is linear expansion? Let's say we have one rod. Okay? We have one rod. So what happens is, when we heat that rod, when we provide heat to that rod, the temperature of the rod increases. So as a result, the length of the rod also increases. So what happens is, in linear expansion, if we have a rod, then on heating that rod, the length of the rod increases, and that is called as linear expansion, right? The second type of thermal expansion that we have is superficial expansion. So what is superficial expansion? Let's say we have a metal plate. There is a metal plate, and what happens is, when we heat that metal plate, the area of the metal plate increases, and that is what called as superficial expansion. And the third kind of thermal expansion we have is cubical expansion. So what is cubical expansion? So suppose we have a body, a three-dimensional body, which is having some volume. It may be a sphere, a cube, a cuboid, or any body having three dimensions, right? So what happens is, when we heat that body, the volume of that body increases, and that is what called as cubical expansion. In linear expansion, the length of the rod increases on heating. In superficial expansion, the area of the metal plate increases on heating, and in cubical expansion, the volume of the body increases on heating. So these are the three kinds of thermal expansion. So please write down their definition. Different types of thermal expansion. So first, under linear expansion, it is the increase in the length of a metal rod. It is the increase in the length of a metal rod on heating. It is the increase in the length of a metal rod on heating. It is the increase in the length of a metal rod on heating. Right? Now write down second type, superficial expansion. Under superficial expansion, please write, it is the increase in the surface area. It is the increase in the surface area of a metal sheet on heating. It is the increase in the surface area of a metal sheet on heating. Third type, cubical expansion. It is the increase in the volume of block on heating. It is the increase in volume of a block on heating. It is the increase in the volume of a block on heating. Right? So these are three types of thermal expansion. We will be discussing them in detail in the next lecture. Right? So please write down one question. The question is, why do solids expand on heating? Now I am saying that the rod will get expanded, its length will increase, the surface area of a metal sheet will increase, the volume of the block will increase. But why do solids expand on heating? So the question is, why do solids expand on heating? Right? So now I'm going to discuss why do solids expand on heating. So what happens is, let's say there is a body, there is a solid body, right? So of course a solid body will be made up of lots of atoms and molecules, right? So a solid body is composed of lot many more atoms and molecules. Now what happens is, at any given temperature, the atoms and molecules of that solid are at some equilibrium distance, right? Now what happens is, when we heat that body, the temperature of the body starts increasing, right? And this energy is gained by the atoms and molecules of that body, right? So what happens is, the amplitude of vibration of the atoms and molecules increases, and when the amplitude of their vibration increases, their interatomic separation increases. The distance between the atoms increases, you can say, right? So their interatomic separation increases, and because of which the solid expands, right? I hope this is clear to you. Why do solids expand on heating? So you can write its answer. Why do solids expand on heating? Write down, all solids consist of atoms and molecules. All solids consist of atoms and molecules. Full stop. At any given temperature, these atoms and molecules are held at certain equilibrium distance by forces of attraction. There is a force of attraction between the molecules and atoms of any body, right? Because of which they are held together. So they are held at a certain equilibrium distance by forces of attraction. Full stop. When a solid is heated, the amplitude of vibration of its atoms and molecules increases. The amplitude of vibration of its atoms and molecules increases. Full stop. As a result, the average interatomic separation increases. As a result, the average interatomic separation increases. Full stop. This results in the thermal expansion of the solid. So I hope it is now clear to you why do solids expand on heating, right? So it is all in this lecture. Now in the next lecture, we will be discussing about linear expansion, superficial expansion and cubical expansion in detail, and we will be deriving an expression for them, right? So it was all in this lecture. So let's meet now again in the next lecture. Till then, keep studying, take care and goodbye.